Hi, Seb.
Hello, Amy. How are you doing?
I'm good. How are you?
Good, good.
Good.
Yeah, yeah. Let's wait for Najim to come if he wants to enter it, right?
All right.
So, how was your practice on the power rule which we did last time?
Oh, yeah, that was good. Just trying to remember it, get the formula in my head, because obviously we can need it later on, and it'll make things a lot easier. So yeah.
Perfect. So, what was that lesson? Easy, difficult, or okay for you?
That wasn't actually too bad. It was all right. The
Okay.
power rule. Yeah.
Okay. Okay. So, let's begin with the lesson two on derivatives. Now, Emmy, we have already done the power rule, which is our lesson number one. We also saw how we could use it in the extended form. I'll share with you the screen now, and we'll see how to work when we are already given the product rule and the quotient rule. In lesson two, we'll discuss product and the quotient rule. Now, in our today's video, we'll also see how to derive this particular formula for the product rule. At times that is not required, but it is always good to understand how did we come to this formula, correct?
Yeah.
Similarly, we will also derive the quotient rule formula in today's lesson, and then we'll actually take up questions related to power rule and to the quotient rule. So let's begin with the summary of what we had done last time. Last time we worked on the power rule, right? And we understood that
Mhm.
gradient can be treated as a derivative. Now, gradient is such an important property, and it has so many applications that we rather give it a name which can be used more versatilely and a notation so that it could be applied easily. So we changed the concepts which we learned about gradients to a new name, which was derivatives. Now, with gradient, you had known earlier how to find slope of a secant line, and when the limit approaches zero, which is right here written, then we get slope of the tangent line. So with gradient concepts, you were able to find slope of a tangent line on a particular curve, or any curve for that matter. Now,
Mhm.
calculus is all about finding gradients at any particular point on any curve. And so we'll now write that gradient concept in the form of dy dx or in the form of f dash of x. So these are the two notations. One is called the prime notation, and the other one is called the Leibniz notation, right? So we are going to use these notations as we move along. Power rule, which we discussed, we also derived the formula for power rule, which came from the binomial theorem expansion. If the function is given in the form of x to the power of n, where n belongs to real numbers, then the derivative is n times x to the power of n minus 1. We also understood that since in derivatives, the binomial which we get is a plus h, where the other term is very, very small. Now, when the other term is very, very small, in that case, n, which we are writing here, which we started with natural numbers or non-negative integers, can be treated as real numbers. So it is a very important concept to always remember that we have made an assumption that in our binomial, the other term is very, very small as compared to 1. And only then the formula really works for all real numbers. So uh, we keep writing like this, n belongs to real numbers, but we have to remember the restriction. Now we also understood the sum and the difference rule. If we have two functions, f and g, then their sum and then derivative is same as their sum of derivatives, or the difference and then derivative is same as derivative of their differences. And we also saw that if you multiply a function by a constant, then the derivative also gets multiplied by a constant. Perfect. So these are
Mhm.
our learnings for lesson number one, and we'll move forward with lesson number two now, where first thing is to derive the formula for the product rule. Now, in product rule, we are looking at two different functions. Let us say that the functions are f and g, right? Product means just multiply them as shown here. If you want to find the derivative using prime notation, I'm writing like this. The dash on the top is the derivative of product of two functions, f and g, okay? And the rule states that it is basically derivative of the first function times the second function plus first function times derivative of the second function. Now, in Leibniz rule, we can also write this as d dx of product of two functions is, first let's talk about the derivative, right? So derivative of the first function times the second plus derivative of the second function times the first. Now, since we are multiplying by a function, we tend to write it before the derivative, right? So that is kind of a nomenclature to use. But you could always switch this to take this, okay? Now, let's look into the proof, which is also based on first principle, right? So first principle is actually the foundation for all this. So let us say we have another function, which, let me admit, Najib. Okay, Najib, can you hear us? Okay, so we'll assume, Najib, that you can hear us, okay? So we'll continue, Amy, with this session.
All right.
Okay, so what we're talking about is that we have product of two functions, f and g, lowercase. Let us say this product is a bigger function, which is capital F of x. We are interested in finding a formula which can be used to find the derivative of capital Fx, that is the product of two functions. Now, going with the definitions of limits, rather derivatives or gradient, you may say, limit of this particular function, f of x plus h minus f of x over h, when h approaches 0, is the derivative, correct? That's the definition. Perfect. Now, since we know what is f, the capital F function, it is product of f and g. So we just wrote here the functions itself in the form of the product of these two. Here?
Yeah.
Okay. Now the trick part. What we actually do to simplify this particular expression is add and subtract a term which is product of f of x plus h times g of x. So we have subtracted this term and we have added this term in the numerator. When you do that, we don't really change the numerator. We are adding and subtracting the same term, correct?
Yeah.
But this adding and subtracting of a term really helps to divide this particular expression into two parts. So in part one, what we are doing is we are taking f of x plus h common. So now look at it from this here. F of x plus h and f of x plus h is common, correct? What are you
Yeah.
left with? You're left with g x plus h and gx. Does it make sense?
Yeah.
And that is limit of h of x, limit of all this when h approaches 0. So that becomes one part of this particular expression. And in the other part, what we are doing here is we are taking g of x common. So here, this is g of x, correct? And there you have g of x. When you take them common, you're left with these two terms.
X plus. Yeah.
Is that clear to you? So that becomes the other term. Now you can easily see that these two terms which are left are definition of derivatives, right? F of x plus h minus f of x over h is the derivative of
F of
fx,
F.
right?
Derivative.
And
Yeah.
g of h plus x minus g of x is derivative of gx, correct? So we
G of
get
X.
these two derivatives. Is that clear to you?
Oh.
Those are the
Yeah.
derivatives. And what you also
And that's
notice,
the product.
yeah, the first term, which is the coefficient of that, f of x plus a. Whenever you're finding derivatives, it is always a continuous function. Otherwise, the derivative will not exist, right? Now, in a
Um,
continuous function, the value of the function is same as the derivative. I mean, the value of h is approaching 0. Is it clear? If I put
mhm.
h approaching 0, I'm left with f of x, correct? So that is how I get this f of x as the coefficient of the derivative of g of x.
Yeah.
On the other side, we have a term g of x, which is independent of h. There is no h in this, correct? So we could write the terms
Yeah.
straight. And that's the formula for the product of two functions derivative. You see that?
All right. Yeah.
So the,
It's good to know that, like where it comes from and how
yeah,
it gets to that.
sure. Have you understood the whole process?
Yeah. That's
Can
clear.
you can you explain me this process?
Yeah. So what we did was we let I'm just going to say capital F of x equals the product of f and g of x,
Yes.
and then we used the difference quotient formula and we subbed those values in. So we got x plus h and we put them in and we subtracted minus f of x, g of x. And the key part is adding and subtracting that highlighted term. So f bracket x plus h, g of x in the numerator and rearrange. So when you put those two in the numerator, you're not actually changing the numerator because that just gives 0. But by doing so, we can split the numerator into two parts, which makes it easy for us to find so the derivative of g of x and the derivative of f of x. Then we just put them into two parts, and when it comes to the last step, so we got as limit as h approaches 0, f bracket x plus h, limit h approaches 0, then the derivative of g of x. The key part to get to the next simplified version is because h approaches 0, in the bracket of f x plus h, the h is just, we can just make it 0, so cancel out. So that would just become f of x, and then you got the derivative of g of x plus g of x because there's no h in it, so you don't need to sub anything in, and then you got the derivative of f of x,
Perfect.
which is the product rule.
Perfect. That is what it is. Now, most of the books might just give this definition and the formula and the derivative also. But here is something extra for you. And that is most important part of this video. What we are now going to understand is how can this rule be extended. The three things which I have shown here is when we talk about product, we just talk about two functions. But you could multiply more than two functions. You could have three functions, correct? If there are three
Yeah.
functions, then the rule is kind of similar. The only thing is you have three functions now. So at this stage, what you do is think like this. Derivative of one of them with product of the other two. Derivative of the second one with product of the other two. Derivative of the third one with product of the other two. That's it. So this
Yeah.
rule can be extended. You see that?
Yeah.
So don't worry if in an equation there are many factors multiplied together to give you the term. Because then
All right.
think like this and find the derivative. Does it make sense to you?
Yeah, that makes sense.
Yeah, and it's a bonus question in some test papers. Now, second part to this is, let us say f and g are same functions. F of x and g of x are same. In that case, when you multiply f of x with g of x, what will you get? F of x whole square, right?
Okay, squared.
Square.
Yeah.
So that is the
They're the
second
same function.
correlation. So if it is square, then using the same formula, we have derivative of first function times the second function. Again, derivative of the first function times the second function. Since both the functions are same, we'll get 2 times the function and its derivative. You see that part?
Yeah.
2
Because you
times.
bring the 2 in front, don't you?
Perfect. So that is kind of a power rule. So kind of you apply the power rule, right? Bring the 2 first,
Ah.
write with to the power of 2 minus 1, and then write the derivative of the function. So it's combination of the two, which is very apparent from the general formula which I have written. So if the power is n, in
Yeah.
that case, n times f of x to the power of n minus 1 times the derivative of inside function. Do you get it?
All right. Yeah.
Times,
That's quite cool. It works with literally any number that n could be.
can you
That's so
explain me
cool.
this part? Can you explain me this part, Amy?
Which one? The last part?
Yeah, these three formulas which I have derived from our derivation.
Yeah, so when you, like you said in the beginning, when we think product rule, we usually think just two terms, two functions, just multiplied together. But obviously, you can have more than two, you can have three, four, and just onwards. So when you do that, just try and think of it when it says the derivative of, let's say, three functions. You take the first function, find the derivative of that, then just multiply the other two functions, then you add, and then you do the derivative of the second function, and then you just do the multiply the other two, then you do the third, and then just carry on
That is,
until how many there are.
yes. And in
Then
case,
we said,
yeah, in case we have the last
sorry.
case where the exponent is n, how will you get the result? Can you explain that?
So like we said, it's actually comes from the power rule. And when it's f of x is say to the power of n, you take the n and you multiply it by f of x
Yes.
and do n minus 1, like we've already done as we talked about in the last lesson. And you have to do the derivative of the function in the bracket.
Perfect. So that brings us to the understanding of product rule. And now let's get into some examples. So I'll have two examples based on the simple rule, product rule, and then we'll have two
Mm.
examples based on the modified rule, right? So here are the two questions for you, which is use product rule to find the derivative. One, y equals to x minus 2 times 3x plus 5. And the second one is y equals to 2x cubed times square root of x plus 5. Now, some of you could also expand this, right? If you expand this, you can apply the power rule, which we learned in lesson 1, correct? These are two
Oh
by
yeah.
you can always expand and get your result. That is also a formula, I mean, a method of doing, which you could always do in your test paper. It will not be wrong. However, we mentioned apply the product rule. So we will have to apply the product rule. Easy way to think about is identify first and the second function. Our first function is x minus 2. So first you have derivative of x minus 2, okay? Multiply by the other function. Then add to this derivative of the second function and multiply by the previous function. Is that clear to you? So simple.
Yeah.
So start with the derivative. In writing, since we are treating that multiplier as a coefficient, we write it before the derivative part. Even otherwise, think about writing it later. You will be confused whether it is derivative of only 3x plus 5 or the product, correct? So
Mm.
avoid that confusion. Is that clear to you? And then it's
Oh right. Okay. Yeah.
very simple derivative, as you can see. Now, the second question. The second question involves that square root, and definitely you cannot expand it using binomial concepts. And therefore, you have to apply the derivative rule. I mean, the product rule, which is again written here for your convenience, right? So once again, identify your first function and the second function. You know, derivative of the first function times the second, then derivative of the second function times the first. Is that clear to you?
Yeah.
Perfect. Now, why am I
Sure.
specifying derivative of the first function first? Because here it actually doesn't matter. We have plus in between. So whether you change their position, it doesn't matter. But we'll soon learn the quotient rule where the center sign will be negative. And if you mix up the order, you'll get a wrong answer. So therefore,
Oh yeah.
right, yeah, so right from the beginning, you have to follow the right way. But I hope this is not difficult to understand. Here is the solution which you can go through. Perfect?
Yeah, that
Yeah.
makes sense.
The
Oh,
next,
just quick thing.
yeah, yeah,
Um, with the square root x plus 5, so
yeah.
you made that into x plus 5 to the half,
Yes, And
And
then
then
half
when you did
times,
the derivative of that,
yes,
half
yes,
times x plus 5 to minus
that is true.
half minus 1. Yeah,
Which is
minus
minus
3.
half,
Is it 3 or 2?
minus half, minus half. Half
Oh,
minus
minus
1
half.
is minus half, so it came in the denominator with the square root.
Yeah, I meant minus half. Yeah, okay.
So when you do that power rule, you practice this a bit. So by this time, you should be in a habit of just writing straight away that square root derivative as 1 over 2, and that square root thing comes in the denominator because it is that to the power of minus half. You get the idea?
Oh, okay.
Now, this
Yeah.
square root function is so common, Amy, that in 50% of the questions you'll have it. And therefore, writing it as to the power of half and then doing the power rule half minus 1 and then to the power of minus half means 3 additional
Too
steps.
long.
We have to avoid it. We have to come straight to
Okay.
this particular answer as shown here. Is that clear to you? So,
Yeah.
so while working with the power rule, which you learned only yesterday, it is good to do the way you explain. But when you come to this unit, you should be a pro at it, right? So just straight away nail it.
Oh,
You understand? That is
yeah.
what we are
Okay.
expecting you. Now, let's take the other two examples, which is extension, and then you will understand the beauty of what I was saying. Now, these are actually bonus questions in many test papers, and students really get confused when they have to apply power rule, and they have three functions as shown here. Do you see that part?
Yeah, because power rule, it won't work.
And the product rule, we have learned only a formula with two functions. Now we have three. So the easy part is pick up
Yeah.
the first function, which is right there. Multiply with the other two. Do you see that? Then pick up
Yeah.
the second function, write its derivative,
Mhm.
multiply with other two. Then take the third function, find its derivative, multiply with other two. Does it make sense? Follow this
Yeah.
order, there could be any number of factors given here, but you can easily find their derivative. Correct?
Hmm.
Perfect. Now, let's take the last question on product rule, which is x squared plus 4x minus 3 to the power of 7. Now, we learned a formula of doing this, Amy, right? Can you
Yeah, the
suggest
one to the end.
one at the end? Can you suggest how are you going to do it?
Yeah, so I would take the 7 to the front and I'll do 7 bracket x squared plus 4x minus 3 to the power of 6.
Perfect.
Then yeah, and don't forget, don't think that's the end of it. Then you have
Yeah,
to multiply it by the derivative of f of x, but in this
correct.
case it's x squared plus 4x minus 3.
Perfect. And when you get that, you may have to simplify, but most of the time, we'll specify in such cases, do not simplify because it's too complicated, correct? So you see
Yeah.
this remark here, do not simplify. So in
All
case
right.
of derivatives, we leave the question right there. But I hope you have understood the part of it. And that brings us to the end of what I wanted to teach you and the beginning of your practice questions. So, Amy, you can take a picture of these questions right there on your page. So here we have 9 questions for you. Practice how to apply the product rule. And once you practice with this, in our next lesson, which is called 2B, I want to give you time in between to digest what all we have learned. We'll actually continue this with the quotient rule. Does it make sense?
All right. Okay.
Right?
Yeah.
So, so Amy, I would like you to summarize what we have learned today.
Yeah. So we learned about the product rule and how obviously you can use it for, we always think two functions, just multiply them together. However, there can be more than two being multiplied. So when that happens, you just do the derivative of the first one times the other two, add the derivative of the second one, multiply the other two, and so on. And when you do that, make sure, it's not a big deal, but it is a big deal when you get to quotient rule. make sure when you do the derivative, write it at the like end of the kind of the sum, and then do the 2 multiplied in the front, and then carry on, because when you get negatives, the signs don't get them mixed up, so it's better to write it in that format. And then we learned, so if it's to the power of like 7, f of x to the 7 or something, you use the power rule, and you take the n, you times it by f of x n minus 1, and then you multiply that by the derivative of the function. And using those formulas, you can easily do questions that are
Perfect.
high marks. So yeah.
That's great. So now, I mean, you are actually ready to do any question in your book on this particular topic. But first, do those 9 questions which I have shared with you. And then we'll be
Okay.
back with the quotient rule. And once we do both product rule and the quotient rule, then we'll have an examination style test paper to solve and practice. Does it make sense?
Oh, yeah. No, that's cool. Thank you so much, sir.
Great. See you then. Thank
See
you and
you.
all the best.
Thanks, sir.